Hello guys, welcome to my last video on Malus's law, polarization and intensity. This is my third segment of my 3-video series, and in this video I'm going to be finishing off some of the questions around Malus's law, around intensity, around polarization. So I really hope that this series was very helpful, and if you have any questions, please ask in the comment section, or if you have any areas of concern or any or any concerns that you have, please point that out. Thank you so much for watching my videos. I hope you can continue to comment, like, share, and please subscribe so that you can continue to watch more of my content. Okay, so let's begin. We're starting off from October-November 2022, question paper 2-1. So this is number 4, where they asked of polarization. So this topic has been asked recently. It's a new addition to our syllabus, especially polarization and Malus's law. So it's very likely that it might be highly examinable in these few years. So it's a very important concept to know. So the first question asks us that polarization is a phenomenon associated with light waves, but not with sound waves. So that's very weird that only light waves can be polarized, but not sound waves. So they want us so they just want us to know if we understand what polarization is. So this is basically more of an appetizer, where they're asking us, what is polarization? Well, polarization is defined as the restriction of oscillations to a single plane or a single direction that is perpendicular to the direction of propagation of the wave. So polarization is basically the restriction, okay? So if we were to put this, it's basically the restriction, okay? Polarization basically, this is the restriction, okay, of the vibrations, right, or of the oscillations, of a wave, okay, to a single direction, right? And that direction has to be perpendicular. So that direction, which is perpendicular, right? Perpendicular to the direction, okay, to the direction of propagation, So basically that is what polarization is. If you have a wave, right, that is moving in a lot of different directions, and if you were to restrict those vibrations to only one plane only, so if it's now vertically polarized, it came off from moving on in different directions, and now it's only vertically polarized. That's basically polarization. You're restricting the vibration of a wave to one direction only. Next question. State why light waves can be polarized, but sound waves cannot. Okay? So sound is actually longitudinal, and light is actually transverse in nature. And that fact means that light can be polarized because it is directions which are perpendicular to the direction of propagation. But sound doesn't have that. It's longitudinal, right? It moves parallel to the direction of propagation. So it can't happen. So light waves, okay? So light waves are generally transverse, right? So light waves are transverse in nature, but sound is longitudinal, right? But sound is longitudinal. And the fact that light is transverse and sound is longitudinal, it means that sound waves cannot be polarized because they're moving in a direction that is actually parallel to the motion, right? So imagine you have something that is already moving in a vertical direction. So if it's like that, or let's compare refractions, compression, refraction, compression, refraction. If you were to put a barrier that's open, all the light will pass through. But if you have those compressions, right, and you have those refractions, you have those compressions and you have those refractions, but if you were to put something horizontal, none of them pass through. So you can never polarize longitudinal waves, but light travels in a variety of directions, hence it can be polarized. Okay, moving on to the next question. We've been given two polarizing filters. Also, we've given filter A and we've also been given filter B. This question will be given two polarizing filters, filter A and filter B, that are positioned so that their planes are parallel to each other, perpendicular to the axis of line XY. So we have this light. So the first light is unpolarized. So it's coming in all different directions and it's coming in all different angles. So it's unpolarized, right? Something like that. And now it's a vertical transmission axis, meaning that the light that comes out is now vertically polarized. So after coming out of that section, it's actually vertically polarized, right? So the light is traveling in that direction, okay? So very important. And then we're now rotating the second filter, right? So the second filter is being rotated. So the question is as follows. We've been asked to calculate the angle of rotation of filter B, given that the intensity of light emerging from filter B is 1/4 I naught. So filter B is rotated so that the intensity that comes out is actually 1/4 of I naught. And we've been asked to find this particular angle of rotation that has caused the intensity to come to that direction. Okay, so what direction do we need to rotate that filter so that it gives us an intensity of I naught? So remember, if you have Malus's law picture in your head, what angle are you trying to have so that the value of theta results in intensity that's 1/4? So is you're opening, or you're turning filter B, you're actually filtering light so that only 1/4 of its intensity actually passes through. So we have to find that angle theta that causes that to occur. Okay, so we know that intensity is actually equivalent to I naught, okay, cos squared of theta, right? So, but the intensity that's coming out is actually 1/4 I naught, right? So the intensity that's coming out 1/4 is I naught, and that is equivalent to I naught cos squared theta, right? So if we cancel this and that, we're left with cos squared theta is actually equivalent to 1/4, right? So cos theta is actually the square root of 1/4, hence theta is actually a cos, right? The square root of 1/4. That gives you your value of theta to be 60 degrees, right? So basically the angle of theta is 60 degrees. That gives me an intensity of 1/4 I naught, right? But remember, Malus's law is about knowing three things: your polarizer, your analyzer, your transmission axis. What is actually your polarizer? This is it, right? Your transmission axis for the first one, something like that, right? So for Malus's law, you only need to know three things: polarizer, analyzer, and transmission axis. So transmission axis for the first light is actually something like that, right? So this is the transmission axis for the first light, something vertical. So we want to rotate it so that it's actually 60 degrees, so, right? So the first thing that you have to worry about is this angle theta. So we draw our vertical axis like that, right? So we're rotating it, but we want theta to be 60. But guys, remember, this is just theta from the vertical transmission axis to the angle of the transmitted light. So if we were to draw this value of theta here, right, this can still be 60 degrees. It's still the same angle theta from the transmission axis of the polarizer to the transmission axis of the analyzer. But this angle is already 90 degrees, right? But that angle, we were at 60 here, this is actually 120 degrees. So 120 minus 90 is how much you need to rotate it. So you need to rotate it 30 degrees, right? So this gives you an answer of 30. You need to rotate it 30 degrees so that the angle becomes 60. Because we want the angle theta to be 60 so that we have 1/4 of the intensity coming through. So it doesn't matter from what angle. Malus's law is about using your transmission axis for the polarizer as a reference angle. You start as the reference angle. It doesn't matter where you read it from. As long as that point is still the reference angle, you can still get the correct answer, right? So the answer becomes 120 minus 90, that becomes 30 degrees. So we need to rotate it 30 degrees, right? So that the angle becomes 60 degrees, right? So it's a bit complicated, but just understand this. Theta is the angle between the transmission axis and the angle of the analyzer itself. That's only that what you need to know. So this is where Malus's law gets tricky, identifying the value of theta. But once you know that I have to find my transmission axis, you draw that on your diagram. You have to find your analyzer, you draw that on your diagram. You can find your value of theta. Moving on to question part C. We've been given a microwave of intensity I naught and amplitude I naught, right? So it meets another amplitude, right? It meets another microwave of the same frequency, but it has a different intensity, traveling in opposite direction. But the waves are vertically polarized, they superpose when they meet. So we have one wave that is moving in this direction, right? So one wave that's just moving in direction, minding its own business with an intensity of I naught, right? Another wave moving in that direction, again, with intensity of 1/4 I naught. The two meet, they interact, they then have what they call an agreement. They decide to superpose, right? So they decide to form a stationary wave, right? But that is not the case. They tell us that we cannot form a stationary wave that is zero amplitude at its nodes. Get this, amplitude is related to the intensity. So if this intensity of I naught has an amplitude of A naught, we know that intensity is directly proportional to K A squared, right? So basically what this means is that if the intensity is 1/4, the amplitude cannot also be 1/4. It has to be different, right? So the amplitude has to be something different. It can't be 1/4, right? It doesn't make sense. So this amplitude actually changes to a certain different value. The mere fact that the amplitude is not the same basically means that these laws no longer apply. It basically means that the mere fact that the amplitude is different, they won't have zero amplitude. So for zero amplitude to occur, one wave, this wave is supposed to come with an amplitude A, that wave with an amplitude A. If they meet in opposite direction, at this point, the amplitude will be equal to 0. At that point, the amplitude will be equal to 0. But it can't happen. These two don't have the same amplitude. So this scenario cannot happen. So it can't have nodes where the amplitude is 0. So that's just what they want us to explain without calculation. So the waves have different amplitudes. Okay? And because they have different amplitudes, they cannot ever have a resultant displacement that is always 0, right? A resultant displacement that is always 0, okay? That is always 0. So the mere fact that they have a different amplitude altogether means that their amplitude at any given point can never be 0, okay? Moving on to other question, we're about to determine in terms of I naught, the maximum amplitude that can be formed. So we just have to use again the law about intensity. So we know that intensity is equivalent to Ka squared, right? So the first scenario, I naught is actually Ka naught squared, but it now goes to 1/4 of I naught. So what is the amplitude that causes that? Well, we just substitute it. We then say that it's now 1/4. So 1/4 I naught is actually equivalent to K, maybe let's say A1 squared, right? So the value of K is actually I naught over A naught squared, right? So 1/4 of I naught is actually equivalent to I naught over A naught squared multiplied by A1 squared, right? So if we multiply both sides by A naught, right, we get 1/4 I naught multiplied by A naught squared, and we get that equivalent to I naught A1 squared. So these cancel out. So our A1 squared is equivalent to 1/4 A naught squared. So A1 is the square root of 1/4 A naught squared. So A1 is actually 1/2 of A naught, right? So the maximum amplitude that we can form is when these two add up. It's when that wave and that wave actually add up. So they add up when we have one wave with A, right, A naught, and one wave with half A naught. If they add up, the total, right, the maximum amplitude would therefore be 1.5 A naught, right? So the answer is 1.5 A naught. So very important. So very important for you guys to look at that, right? So actually this was graded on the fact that you knew this relationship. The mere fact that I is directly proportional to A squared, just stating this statement gives you a C1 mark. It gives you a mark that you know this formula. So I would advise that you write every single step that you're doing, right? The next step came from finding this amplitude itself, right? This is where you got your second mark, and your last mark is for your answer itself, right? So remember, write the equation. What do you know? The intensity is reduced to 1/4, right? So write that equation down, right? And then you ask yourself, if you return to 1/4, your value of K, you know it, you multiply both sides by that. That means that your amplitude A1 is actually related to A naught by that equation. So A1 is actually the square root of that. So A1 is actually half of A naught. So you can find the total, which is 1 plus half, which gives you a total of 1.5, which is the answer that we got here. Basically, that's it for this paper. So it was just about understanding what polarization is. So they just gave us a feel of the concept itself, and they just wanted us to explain why it happens with light waves, but it doesn't happen with sound waves. So they gave us this question which tested our understanding of Malus's law. Do we really know this angle theta? It's basically the angle between two transmission axes. So we just want this angle to be 60 degrees, right? So what they were looking for is just stating this equation itself, right? Stating this equation gives you the first mark, so that you can be able to show them that you really know what this angle actually is. And finding the angle of 60 itself is the other mark. But just knowing that for 60 to be formed, I can rotate this 30 degrees so that I reach this angle of 60 that gives you your last mark, so that you have a total of 3 marks. And then we talked of how waves can have different amplitudes, right? That's very important. And how they cannot form a resultant displacement that is always 0 because they have different amplitudes. You can't have something that has 2A, something with 1A, and you tell me that they can form 0. It can't ever happen, okay? And then the last question was for us to find amplitude, right? Relate the law that we really know about intensity. Moving on to February, March 2023, question paper 1-2. So we've been given a beam of vertically polarized light that is incident normally on a filter. Okay, so the filter can be rotated. So the filter can be rotated. Okay, so welcome to. Okay, so the last one is on February, March 2023, question paper 1-2. Is question 24. So we've been given a beam of vertically polarized light that is incident normally on a polarizing filter. So the filter can be rotated so that it is always in a plane perpendicular to the beam. Okay. So the transmission axis is initially vertical. So the waves that are coming in, they are initially vertical. Okay, so this is the waves that are coming in. So we're given light that is vertically polarized and is reaching this transmission axis of the polarizing filter, and we've been asked to find the new intensity of the transmitted light waves. Also, the first filter is rotated clockwise by an angle of 30. So that it has an intensity of I0, which is 30, right? So it is then rotated by a further angle of 30 degrees, and we've been asked to find the new intensity of the transmitted wave. Okay, so let's look at this, right? So basically, we know that I is equivalent to I0 cos, okay? So I is equivalent to I0 cos squared of theta. Right? So initially we've been given I30, right? So I30 is basically after we have rotated our angle to a particular degree, right? So I30 is actually equivalent to I0, the light that comes in, right, which is I0, cos squared of 30. So first it's rotated at an angle of 30, so always ask yourself, what is your 3 things? You need your polarizer, your analyzer, and your angle. So your polarizer has that angle, and the analyzer is at that angle. So this particular value of theta is actually 30 degrees, okay? So I30 is actually equivalent to I0, right? So cos squared of 30 is actually 3/4. So it's actually equivalent to 3/4 of that particular value. But here's what's happening. The filter is then rotated clockwise by a further 30 degrees, right? What this means is that the new angle is now 60 degrees. So the angle has now shifted, and this angle is now 60 degrees. So it's probably situated like that, such that this angle is now 60 degrees. So how do you find that one out? It's again, I60 is equivalent to I0 cos squared of theta, right? So I60, you ask yourself, what is your I0? What is your cos squared? It's cos squared of 60. Cos squared of 60 is actually 1/4. So I know I60 is actually I0 times 1/4. Therefore, I60 is actually 1/4 I0. Okay, so you get your value of I60, but you know that I60, I0 is actually here, right? From this equation, the value of I0 is actually 4/3. So I0 is actually 4/3 I of 30, right? So I60 will be, you substitute the value of I0, so it'd be 1/4 times 4/3 I0 of 30. So that gives you a total value of I60, which will be 0.33 I of 30. So the answer becomes B. The answer is actually B. So remember, the most important thing that we had to look into this question was, do we really know this law, right? And we find I30, which is the first one, in terms of a common angle I0, right? So the angle was rotated at 30 degrees, so that is 30. So we got this expression, right? But we thought that we rotate it further by 60, meaning that that angle is actually now different. So I just went back to my normal reference. If it's at 60, I then said I60 would then be I0 cos squared of 60. So I got I60 in terms of I0, but I already know what I0 is from this expression, right? So since I had that expression, I was able to express I60 as a quarter of I0, and I was able to get the value of I60 to be 0.33 I0 or I30. So basically, this is a bit about Malus's law. So, right. So this is a question from May-June 2023, question paper 1-1. So I'd highly recommend that you watch my video. Now that you have an understanding for Malus's law, I'd highly recommend that you try this question out. Remember, in this question, you just have to know what is your value of intensity that comes out, right? And always ask yourself, what angle am I trying to find? What angle am I given? For example, in this one, I can just give you a hint. The light is vertically polarized, right? So it's the first transmission axis is actually like that. But the question has been a bit tricky. It is giving you this angle. So you just have to find the other angle and make your ratios and arrive at the appropriate ratio of amplitude that you need to find. So I won't give you the answer, but I recommend that you watch my video for May-June 2023 question paper 1-1. I solved the similar problem, but I really hope that you try to answer this question on your own so that you can practice skill of question solving, so that you can be familiar with different questions and how to answer different questions as they come. Thank you guys for watching. So this is the end of my series for Malus's law and polarization, and I hope it was helpful. So I'll see you in the next one. Please comment, like, share, and subscribe. So I would recommend that you check out my video for Malus's law, okay? And my first video that I solved for polarization, as well as the question paper for May-June, okay, 2023, right? So I'd recommend that you watch those videos out. Thank you. I'll see you in the next one.